Think of AI risk like an iceberg. Most organizations see the tip. They worry about a model giving a wrong answer. But beneath the surface, there's data risk, model risk, operational risk, and security risk, all interconnected and all capable of sinking the ship. In this video, we are going to map out the full AI risk taxonomy. We'll cover each category, show you how they interact, and connect them directly to Domain 3 of the AAIR exam. By the time we're done, you'll be able to look at any AI system and immediately identify where the risk hotspots are. That's not just exam knowledge, that's the mindset of a true AI risk professional. Let's get started. Let me ask you something. When you think about AI risk, what comes to mind first? For most people, it's the model itself, maybe a bias prediction or a hallucination. But AI risk is much broader than that. AAIR organizes risk across multiple categories: data risk, model risk, operational risk, ethical risk, and security risk. And here's what makes this interesting. These categories don't sit in separate boxes, they interact. A data risk, like corrupted training data, can trigger a model risk, which then causes an operational failure, which leads to a compliance and reputational crisis. It's a cascade. When I was working on an AI governance review for a financial services client, we found that a data quality issue in the training pipeline was causing the model to behave differently on weekends than on weekdays because transaction patterns differed. Nobody had noticed for months. That's exactly the kind of interconnected risk that Domain 3 of the AAIR exam puts in front of you. So let's go through each category and understand what risk looks like in practice. Let's start with data, because everything in AI begins and ends with data. The first concern is privacy. AI systems often ingest vast amounts of personal data. GDPR in Europe, DPDP in India, CCPA in California. They all impose obligations on how that data is collected, stored, used, and deleted. If your AI system trains on personal data without proper consent or legal basis, you have a regulatory exposure before the model even runs. The second concern is data integrity. What happens if someone tampers with your training data? This is called data poisoning, and it's a real attack vector. An attacker who can influence what the model learns can fundamentally corrupt its outputs. The third is data security. Who has access to your training datasets? Are they encrypted? Is the pipeline secured? Training data is a valuable and sensitive asset. It needs the same controls as any other critical information asset. And finally, data minimization. Collecting only what you need isn't just good privacy practice. It reduces your attack surface and your compliance risk. Think of your training dataset as the foundation of a building. If the foundation is compromised, it doesn't matter how well designed the rest of the structure is. Now let's talk about model risks, because this is where AI gets uniquely dangerous compared to traditional software. The first one is adversarial attacks. Imagine crafting an image that looks perfectly normal to a human, but causes an AI model to misclassify it with complete confidence. These are adversarial inputs, carefully designed to fool the model. They're used in fraud, in evading detection systems, and in manipulating AI-driven decisions. Then there's prompt injection, specifically relevant to large language models. A malicious user crafts an input that hijacks the model's behavior, making it ignore its system instructions. Think of it like social engineering, but for AI. Model interpretability is another major risk. When an AI model can't explain its decisions, human oversight breaks down. Regulators increasingly require that decisions affecting individuals can be explained. A black box model creates accountability gaps that are very hard to close after the fact. And finally, supply chain attacks on AI models. If your organization downloads a pre-trained model from an open repository, that model may have been trained in ways you have no visibility into. It could contain embedded biases or even malicious behavior. Third-party model risk is real. Here's where AI risk intersects with traditional enterprise risk management, and where many organizations are caught off guard. The most common operational risk in AI is model drift. A model trains on data from last year. The world changes, user behavior shifts, market conditions evolve, and the model starts performing worse. Not because anything broke, but because the reality it was trained on no longer matches the present. Drift can be gradual and invisible until it causes a significant failure. Then there are integration failures. AI systems don't operate in isolation. They interact with databases, APIs, other software systems. When those integrations fail, when data formats change, when APIs get updated, AI systems can break in unexpected ways. Sustainability is an emerging operational risk too. The compute and energy costs of running AI models at scale are real line items on the budget. And finally, accountability gaps. When an AI system makes a wrong decision, who is responsible? If the answer is unclear, you have a governance problem. And governance problems become operational problems very quickly. Operational risk in AI is about making sure the system keeps working correctly and that someone owns the responsibility when it doesn't. Let me share something that surprises a lot of risk professionals when they first hear it. AI models themselves can be stolen. It's called model theft, and it works like this. An attacker sends thousands of queries to your AI system, observes the responses, and uses that data to reconstruct the model's internal logic. They've essentially stolen your intellectual property through the front door. No hacking required. There's also model inversion, where an attacker works backward from a model's outputs to reconstruct the training data. If your model was trained on medical records, a sophisticated attacker could potentially recover private patient information from the model itself. And then there's the dual-use problem. The same AI that defends your organization can be weaponized by adversaries. AI that detects fraud can be used to generate more convincing fraud. AI that detects phishing can help craft better phishing emails. This symmetry is a core challenge in AI security. What this means for risk professionals is that AI infrastructure, the models, the APIs, the inference engines, must be included in your security architecture and threat modeling. AI is not exempt from traditional security controls. It needs them more than most systems. Let's bring this all together with the concept of trustworthy AI, because this is where the AIR exam pulls everything together. ISACA's framework identifies several attributes of trustworthy AI: valid, safe, secure, explainable, fair, and privacy enhanced. Think of these as the standards your AI system must meet to be considered responsibly deployed. When any of these attributes is missing, you don't just have a technical problem, you have a risk exposure. An AI system that isn't explainable can't be audited. One that isn't fair creates legal liability. One that isn't secure is an attack vector. Regulatory frameworks are now codifying these expectations. The EU AI Act mandates human oversight, transparency, and bias testing. NIST AI RMF builds governance around these same trustworthiness attributes. And here's the practical takeaway. Accountable AI requires documented ownership, audit trails, and the ability to override AI decisions when needed. That means policies, procedures, monitoring, and governance structures, not just good intentions. As a risk professional, your job is to evaluate whether your organization's AI systems meet the trustworthiness bar. And if they don't, your job is to define what it will take to get there.